Hello everyone. So once everyone joins, so we'll be starting the topic. Okay, so today we are going to start the topic of one-dimensional heat equation. It is also known as diffusion equation. Okay, so starting with the concept that we have been provided with the equation that is curly 2u over curly x square is equal to 1 by c square curly u by curly t. That be equation number 1. What we have to do, we have to derive the heat distribution function from this equation, and heat distribution function is what? That is u. That is heat distribution function and depends upon the variable of x and t. Okay, so here u is the function of x and t both. Therefore we can write u as x into t. That will be equation number 2, where capital X is the function of small x only and capital T is the function of small t only. Okay, now in this statement we have taken partial derivative of u twicely with respect to x and partial derivative of u single time with respect to t. So we can write curly u by curly x as x dash t and curly 2u by curly x square is equal to x double dash t, as well as curly u by curly of t is equal to xt dash. Now I am substituting all the values in this equation number 1. So equation 1 reduces to x double dash t is equal to 1 by c square xt dash. Okay, now I am dividing both sides with xt. So x double dash t over xt is equal to 1 by c square xt dash over xt, and this t and t cancel out, x and x cancel out. So what we are getting now, x double dash over x is equal to 1 by c square t dash over t, and let be equal to some constant k say, and we name this as equation number 3. Okay, now what are the possibilities for k? Now k can be positive, k can be negative, and k can be equal to 0. Now these are the 3 possibilities and we have to work upon that one. So let us consider case number 1. So in case number 1, if k is 0, that means k is equal to 0. So in that case, x double dash over x equal to 0, as well as 1 by c square t dash over t is equal to 0. So we can say x double dash is equal to 0 and t dash is equal to 0. So now integrating this part with respect to x, so it will be x dash is equal to c1. Again integrating, so it will be x is equal to c1x plus c2. Now integrating this part, so we'll get t is equal to c3. So these are the value of x and t. So substituting both the values in equation number 2, that was u is equal to xt. So that will be c1x plus c2 and c3. So this is your next first we can say first solution, that will be equation number 4. Okay, now case number 2. So let us suppose that k is positive. Now if k is positive, that is we take k is equal to p square, because square of any number is always positive. So that's why I have taken square, where p belongs to any integer. It can be positive, it can be negative. So square will make it a positive part. So that means now I have to substitute in equation number 3, that is x double dash over x is equal to p square and 1 by c square t dash over t is equal to p square. So it will be x double dash is equal to p square x and t dash over t is equal to c square and p. Okay, now it will be d square minus of p square. That is what? That is the symbolic form. And here we are going to take integral. So it will be d square is equal to p square. We can say d is equal to plus minus of p. Therefore, the values of x will be c1 e raised to power minus of px plus c2 e raised to power of px. Here if we integrate, so it will be log of t is equal to c square p square and t. And then if I take t is equal to, I take log on the other side, so it will be e raised to power c square p square t, with a constant should be introduced. So these are the two values of x and t. Now substituting in equation number 2, that was u is equal to xt. So that means c1 e raised to power minus of px plus c2 e raised to power of px into c3 e raised to power c square p square and t. So this is our second solution, possible solution for heat equation. Let be equation number 5. Okay, now till this step we have done for k equal to 0. We have done for k is positive, that means we have taken p square. Now the next case is case number 3. If k is negative. So what about negative number? So if I take k is equal to p square, it will be a perfect positive number. And if I take a negative sign in front of it, so since we know that p square is always positive, and taking a negative sign in front of it will make it a negative number always, where p can be any positive integer or negative integer, hardly matters to us for that one. So therefore from equation number 3, we get x double dash over x is equal to minus of p square and 1 by c square t dash over t is equal to minus of p square. Okay, so it will be x double dash is equal to minus of p square x and t dash over t is equal to minus of c square p square. So symbolic form I am converting into symbolic form. So d square plus of p square of x equal to 0. So d square plus of p square is equal to 0. That is its auxiliary equation. This was its symbolic form. Okay. So d square is equal to minus of p square. We can say d is equal to plus minus of iota p. So for this one we have x is equal to c1 cos of px plus c2 sine of px. How we got this one? Since if we are aware that we have alpha plus minus iota b as a root, so in that case cf, that is complementary function, will be e raised to power alpha x c1 cos of beta x plus c2 sine of beta x. Now in this case what we are having, we have alpha as 0 and beta as p. So I substitute alpha as 0 and beta as p. Okay, so after substituting we get this result. Now for the second case, integrating both sides, so it will be log of t is equal to minus of c square p square t. So t will be equal to c3 e raised to power minus of c square p square and t. So these are the values of t and x. Now substituting in equation number 2, so we get u is equal to c1 cos of px plus c2 sine of px into c3 e raised to power minus of c square p square t, and let it, we denote this one as equation number 6. Now till this step we have obtained three possible solutions. Therefore the three possible solutions of equation 1, that was heat equation, are. So what are the possible solutions? The first one solution was C1x plus C2 into C3. Second was C1 e raised to power minus of px plus C2 e raised to power positive px into C3 e raised to power c square p square and t. And the last one what we have, C1 cos of px plus C2 sine of px into C3 e raised to power minus of c square p square t. Okay, these are the three possible solutions or outcomes for us. Okay, now we'll take a question for this one to solve it. So that means we basically what we are doing, we are having three constant in this question, that is C1, C2 and C3. So we require at least three boundary conditions to solve it exactly. Okay, so let us take a question. Now the question is, a rod of length L with insulated sides is initially at a uniform temperature U0. Its ends are suddenly cooled to 0 degrees Celsius and are kept at that temperature. Okay, so what we need to find the temperature function. Find the temperature function u of xt. So we have to find this one. Okay, so first of all just note this down. So we'll be doing this question, solving this question now. Now when the statement is given to you and you are aware that it is a heat equation, and until the examiner asks you to solve the solution for a heat equation, don't need to solve the whole solution which we have done above. You need to just start with the three boundary conditions. Only just state this: we are having a problem of heat equation, one dimensional heat equation. This is the statement and this is the differential equation for this one, and the possible solution for this equation are these one. After that you can just apply the boundary conditions and solve it. Okay, so let's solve this one. So solution is given now. The given problem is related to one-dimensional heat equation, that is curly 2u by curly x square is equal to 1 by c square curly u by curly t. That will be equation number 1, where u is the function of x and t both. Therefore we can write u is equal to x into capital T. That's your equation number 2, where capital X is the function of small x only and capital T is the function of small t only. Okay, now after that we don't need to solve the article, we can write the possible solutions. The possible solutions of equation 1 are, you need to mention all the three solutions. U is equal to c1x plus c2 and c3. U is equal to c1 e raised to power minus of px plus c2 e raised to power positive of px into c3 e raised to power c square p square t, and u is equal to c1 cos of px plus c2 sine of px, c3 e raised to power minus of c square p square and t. So let it be equation number 3. This is your equation number 4, and this will be your equation number 5. Okay, these are the 5 equations. Now we know that heat is flowing from one end to the other end, or from one point to the other point. That means there is a flow. So whenever there is a flow, we always move or travel in trigonometric forms. So that means we have equation number 5 as most compatible equation. Okay, so among the above three equations, only equation 5 is most compatible to the given boundary conditions of heat equation. Now what are the boundary conditions basically? A rod of length L. So we have a rod whose length is L. So this is our rod. So this is the length of the rod. So that means here we have x equal to 0, and here we are having x is equal to L. Okay. Now is initially at a uniform temperature U0. Initially, that what does it means? That at time t equal to 0. Initially means at time t equal to 0. Okay, so for that one, what we are going to do, we are going to take the conditions now. So that means, and what are the other conditions? Its ends are suddenly cooled to 0 degrees Celsius, and I think so both ends are at 0 degrees Celsius and are kept at that temperature. Find the temperature function. So that means the boundary conditions are at x is equal to 0, u equal to 0, at x is equal to L, u equal to 0, and the third condition at t equal to 0, u is equal to u0. That is the initial temperature. Okay, so the boundary conditions are at x is equal to 0, u equal to 0, at x is equal to L, u is equal to 0, at time t equal to 0, we write u is equal to u0. Always plot a diagram for such type of problems, because from the diagram you will be easily able to write down all the boundary conditions. Okay, so we are going to apply one by one. So at x equal to 0, u equal to 0. So equation 5 reduces to 0 is equal to c1 cos 0 1 plus c2 sin 0 0 into c3 e raised to power minus of c square p square t, as I have written over here. Okay, since we yesterday we have done the concept of the wave equation, in which it was c1 cos of px plus c2 sin of px, c3 cos of cpt plus c4 sin of cpt, and we are applying the condition on x only. So that means the term of t is independent of it. So that means c1 into 1 c1, c2 into 0 0. So that means c1 is equal to 0. I am again explaining you that from the first boundary condition we will be getting the value of c1, yeah, as we have done yesterday. From the second boundary condition we will be getting the value of p, that will be basically n pi by length of the rod, and from the third boundary condition we will be getting the value of bn. Okay, Now substituting this value of c1 in given equation number 5, so we'll be getting u is equal to c2 sine of px c3 e raised to power minus of c square p square t, and let be equation number 6 now. Now next boundary condition is at x is equal to L, u is equal to 0. So equation 6 reduces to 0 is equal to c2 sine of px into pl into c3 e raised to minus of c square p square t. Now we are again aware we are applying the conditions on x, so that means t is independent. From this one we get c2 sine of pl is equal to 0. Now two possibilities are there, that is either c2 is equal to 0 or sine of pl is equal to 0. Now c2 is not possible to become 0. Why? If I take c2 as 0, if I substitute in this one, so it will make the whole of the solution distribution temperature distribution u as 0. So we don't need this value, c2 is equal to 0. Okay, that means we have sine pl equal to 0. So pl is equal to n pi, so p is equal to n pi by l. So these are the standard values as I've already mentioned over here. Okay, so we need to substitute this value in equation number 6. So equation 6 reduces to u is equal to c2 sine of n pi x by l into c3 e raised to power minus of c square. Now p square, what is p square? N square pi square over l square into t. So this is the value of the u. Now I'll take c2 c3 sine of n pi x by l into e raised to power minus of c square n square pi square over l square into t, and let it be equation number, I think so it will be 7. And then we'll take this c2 c3 as bn, because x is depending upon sine part. If it depends upon cosine part, this x depends upon cosine part, so we'll be taking this c2 c3 as an using Fourier series. Okay, so you can mention here also, that is equal to summation bn sine of n pi x by l e raised to power minus of c square n square pi square over l square into t. Name it this equation as 7 instead of this one. Okay, so this is the value of u of xt. Now the last boundary condition, that is at time t equal to 0 u is equal to u naught. So this is what u naught is equal to summation of bn into sine of n pi x by l into e raised to power 0. Something power 0 is always 1. So we are left with the condition u naught is equal to summation bn sine of n pi x by l. Now what we need to find the value of bn. So using Fourier series, so bn will be equal to 2 by length of the rod, 0 to length of the rod. Now this function to be written over here into this part to be written over here into sine of n pi x by l into dx. Okay, since u naught is constant, so I'm taking it outside, so 2 u naught over l. So we are having with integration 0 to l sine of n pi x by l into d of x. So it will be 2 u naught by l. Now integration of sine will be minus cos of n pi x by l over n pi by l. So it will be 0 to l. Okay, so 2 u naught over l into n pi, here it is l, minus cos of n pi. Now when I substitute upper limit, l and l cancel out, so it will be n pi, minus and minus plus. Now cos 0 will be 1. Okay, now this l and l cancel out again, 2 u naught over n pi, this one I am writing in front, minus cos n pi is what? That is minus 1 raised to power of n. Now here we need to discuss the case of even and odd function. So here if n is even means square power 4. So minus 1 is square, that will be 1. So 1 minus 1 0, 0 into something 0. And if n is odd, in that case what will happen? Minus 1 is to 1, so it will be minus 1. 1 minus minus 1 will be 2. 2 to the 4. 4 u naught over n pi. So this is what? This is the value of bn. Now I need to substitute this value of bn in equation number this 7. Okay. So substituting in equation number 7, so we'll be getting u of xt is equal to summation n is equal to, for odd only, okay, 4 u naught over n pi into sine of n pi x by l into e raised to power minus of c square n square pi square over l square into t. Maximally what you can do, you can take 4 u naught over pi common, summation n is equal to odd 1 over n into sine of n pi x by l into e raised to power minus of c square n square pi square over l square into t. Now this is your final solution for the given statement problem. Okay, hope it's clear to everyone. Now here, whatever be the value of L, you need to substitute those value of L over here and here. Okay, whatever be the value of L, it can be 1, 2, 10, 20, 30, whatever it be. So you need to solve that one. Okay, so after that we move towards one more question. Here we are taking difference of temperature. Okay, two temperatures are there. Now here the statement is the ends A and B of a rod of length 20 centimeter. Now we have given the length, that is 20 centimeter, are at temperature 30 degrees Celsius and 80 degrees Celsius until steady state prevails. Okay, then the temperature of the rod ends are changed to 40 degrees Celsius and 60 degrees Celsius respectively. Find the temperature distribution function u of xt given that c square is equal to 1. Now what is c square? In such type of question, c square can be specific, can be dependent upon specific heat, density and thermal conductivity. Okay, so it can be varied question to question. So we have to solve this question. First of all, we understand what is the statement now. Now we have a rod whose two endpoints are named as A and B. So we have a rod with endpoints as A and B. Okay, of length 20 centimeters. So that means this length is 20 centimeters. So here we can mention at x equal to 0. Here we can mention at x is equal to 20. Are at temperature 30 degrees Celsius. So here we have given u is equal to 30 degree, and here we can mention u is equal to 80 degree until steady state prevails. Steady state prevails, that means whenever the temperature at higher this one flows towards the lower temperature. Okay, and the whole of the temperature of the rod will be same throughout. After that, what they have given, then the temperature of the rod ends are changed. So they have changed the temperature to 40 degrees Celsius. So at this one we have changed to 40 degrees Celsius, and to this one it is 60 degrees Celsius respectively, and find the temperature distribution function. So from the statement it is clear that it is a problem from one-dimensional heat equation. Okay, the given statement problem belongs to one-dimensional heat equation, that is curly to u by curly x square is equal to 1 by c square curly u by curly t. But they have given c square is equal to 1, so that means curly to u by curly x square is equal to curly u by curly t. That will be your equation number 1. Similarly, u is a function of x and t, so u is equal to x into capital T, and the possible solutions for equation 1 are u is equal to c1x plus c2 into c3, u is equal to c1 e raised to power minus of px plus c2 e raised to power of px, c3 e raised to power of p square t. I am substituting c square as 1, okay? And the last u is equal to c1 cos of px plus c2 sine of px into c3 e raised to minus of c square, that is 1, into p square and t. So that this equation I'll take 2, this is equation number 3, and this is equation number 4. Now given after knowing these all boundary conditions, we are again aware that since temperature is increasing and we have to work on the rate of flow of heat, so that means we are aware and we have to use trigonometric term. So therefore, from the above 3 equations or 3 solutions, only equation 4 is compatible. Okay, compatible. Therefore, we will take u is equal to c1 cos of px plus c2 sine of px into c3 e raised to minus of p square and t, which was your equation 4. We will be going through this one. Now coming about the statement again, there was a term steady state prevails. So in such type of questions we don't apply the boundary conditions directly. Okay, so what we have to do, so we have to find the temperature distribution in the rod. So initial temperature distribution, let be u1, that is equal to what? That is equal to whatever be the initial temperature, this initial temperature plus final temperature, so it was 80, minus of initial temperature into the displacement x over the length of the rod, that is 20. So what we get, 30 plus 50 by 20 x. So these two cancel, so we get 30 plus 5 by 2 of x. Okay, now this was the initial temperature distribution. And what about the final temperature distribution? Final temperature distribution, they have mentioned that be u2. So u2 was initial temperature plus final was 60 minus of 40 divided by length of the rod into displacement. So it will be 40 plus 20 over 20 into x. So these two cancel out. We are left with 40 plus of x. Okay, so the final temperature now, therefore for given scenario, heat distribution function is u of xt is equal to, now final temperature distribution, that is what, that is 40 plus of x plus the equation, that is equation number 4. Okay, here we take this equation as initial temperature, that means at time t equal to 0. Okay, this boundary condition will be used for that part, plus c1 cos of px plus c2 sine of px into c3 e raised to power minus of p square t. That be equation number, I think so it was 5. Now I'll again repeat the steps, this one till this step, equation number 4, you have mentioned that these are the statement for general heat equation. Now here in this statement, what we are having, we are having steady state prevails. That means there is a there are two cases. First case, what we are having, at initially we are having temperature as 30 and here we are having a temperature 80. That is the initial conditions. After steady state prevails, the next condition is temperature at end A is 40 and temperature at end B is 60. So these are the two different categories over there. So what I do, initially I take the initial condition. So for initial temperature distribution, so it will be the initial temperature plus this is the final temperature minus initial temperature divided by length of the rod into displacement function x. So after solving we get 30 plus 5 by 2x. That is what initial, that is at time t equal to 0. It will be helpful when you are solving the value of Bn. Okay. Now the final temperature distribution. This was the final temperature, that is 40 and 60. So at 40 and 60 what we are having? So 40 is the initial temperature plus 60 at end point B. So 60 minus of 40 by 20 into x, that is equal to 40 plus 20 by 20 into x over 40 plus of x. So this is temperature at end A, this is temperature at end B, then temperature at A, this is the length of the, and this is the displacement function f of x. Okay. So finally we get this heat distribution function. Now this one. So the first boundary condition which we are having, that is at x is equal to 0, u equal to 0. At x is equal to length, that is 20, u is again equal to, sorry, u is not 0, u is 40 and here u is 60. Okay, 60 degree and 40 degree. So substituting these values, so equation number 5 reduces to, so the value of 5 will be come out to be 40 is equal to 40 plus of x, x is what, that is 0, plus c1 cos 0 1 plus c2 sin 0 0, c3 e raised to power minus of p square and t. So 40 is equal to 40 plus c1. Now this value we have to ignore that one. So from this condition we are having the value of c1 as 0. So your equation 5 reduces to u of xt is equal to 40 plus of x plus c2 sine of px into c3 e raised to power minus of p square and t, and that will be equation number 6. Next boundary condition, that is at t x equal to 0, x equal to 20, u is equal to 60. At x is equal to 20, u is equal to 60. So that means equation 6 reduces to 60 is equal to 40 plus of 20 plus c2 sine of px c3 e raised to power minus of p square and t. So 40 plus 20 is 60 and this is 60. So 60 cancel out, is equal to c2 sine of px. We have to ignore this one. Again the same procedure. So c2 cannot be 0. So sine of px is equal to 0. So px is equal to n pi. So we get p is equal to n pi. Now x was 20, sorry. Yeah, it will be 20 over here. 20. N pi by 20. Okay, substituting this value in equation number 7. So you will be getting u is equal to what? U is equal to 40 plus of x plus c2 sine of n pi x by 20 into c3 e raised to power minus of p square. So it will be n square pi square over 400 into t. Okay, so rewriting it as 40 plus of x plus c2 c3 sine of n pi x by 20 into e raised to power minus of n square pi square t over 400, and let it be equation number 8. Okay, so this is your equation number 8. Now we have to move further. Now next is at time t equal to 0, we have given u is equal to what we got initial 30 plus 5 by 2x. U is equal to 30 plus 5 by 2x. So equation 8 reduces to 30 plus 5 by 2x is equal to 40 plus of x plus c2 c3. That is what, that is your bn now. Summation bn sine of n pi x by 20 into e raised to power 0. So I am taking all the terms on the other side. So 30 minus of 40 plus 5 by 2x minus of x, that is equal to summation bn sine of n pi x by 20. So 30 minus of 40 minus 10 plus 5 by 2 minus 1, so it will be 3 by 2 of x is equal to summation bn sine of n pi x by 20. Okay, so now we need to find bn. So by using Fourier series, in Fourier series using Euler formula, we know that bn is equal to 2 by length. Length is what? 20. 0 to length into this function, that is minus 10 plus 3 by 2x into this part sine of n pi x by 20 into d of x. So 2 by 20, that is 1 by 10. Now this is what? This is your u and this is your v. So u as it is. So minus 10 plus 3 by 2 of x as it is. Integral of sine, that will be minus cos of n pi x by 20 divided by n pi by 20. Minus, now derivative of this one. Derivative of minus 10 will be 0 and derivative of 3 by 2x will be 3 by 2. Now integration of this one, minus as it is, cos will have integral sine of n pi x by 20 over n square pi square over 400. Next derivative will be 3 by 2 will be 0, so no need to write that part. So it will be 1 by 10 minus 10 plus 3 by 2x and 20 over n pi into minus cos of n pi x by 20 minus and minus plus 3 by 2 into 400 over n square pi square into sine of n pi x over 20, 0 to 20. Now upper limit, that is 20. So 1 by 10, 25 to 20 over here, 20, 2 tens are 20. Okay, 10 3s are 30, 30 minus of 10, that will be 20 into 20 over n pi into minus, now if I substitute 20 over here, 20 and 20 cancel, cos n pi, that is minus 1 raised to n plus 2 ones are 200s are 200 into 3, so it will be 600 over n square pi square. Now if I substitute 20 over here, 20 and 20 cancel out, sine n pi is what? That is 0. I'll write over here sine of n pi is equal to 0. You need to try this one. This is the upper limit. Minus lower limit 0. So minus 10 plus 3 by 2 into 0, so it will be minus of 10 into 20 over n pi into minus cos of 0, that will be 1 plus sine 0 will be 0. So we have 1 by 10, 20 into 20, 400 with negative sign minus 1 raised per n over n pi. This part is 0, minus and minus plus and minus minus 20 over n pi. Okay. So just taking the value of 20 over n minus 1 by 10 into 20 over n pi as common. So it will be again 20 into minus 1 raised per n plus 1. Hope this till this step everything is clear to you. So now what we have to do, we have to solve this value for n is equal to odd or even, 0 and 0 cancel out. So we get minus 2 over n pi and 20 into minus 1 raised to n plus of 1, this one, and then I have to substitute this value in equation number, the value where we start with bn, that is equation number 8. Over here I need to substitute here. So in substituting all the values in equation number 8, so your u of xt will be equal to 40 plus of x plus summation of n from 1 to infinity minus 2 over n pi 20 into minus 1 raised to n plus of 1 into sine of n pi x by 20 into e raised to minus of n square pi square 400 into t. So this will be your final answer. Okay. So if you have any doubt, you can discuss it right now or even you can discuss it later on also with me. You can text me and we can solve that concept. Any doubt till the steps, you can have a discussion right now. You can write in the chat box. I will be discussing for that one if you have any doubt. Okay, I think so, no doubt is there. So that's it for today. Now tomorrow we are going to consider the next concept of heat equation, okay, in which we are insulating and we use insulating property. So we'll be discussing that one tomorrow same time. I will be live at 8:30 p.m. That's it from my side. Thank you.